Right, we need to solve for m plus n, and we have been given 2 to the power m plus 2 to the power n equals 544. And we present a solution to this exponential equation, but we present the solution in a step-by-step fashion as follows. We have 2 to the power m plus 2 to the power n equals 544. 544. And this is 2 to the power m plus 2 to the power n equals 2 to the power 5 times 17. 2 to the power m plus 2 to the power n equals 2 to the power 5. 17 is the same as 2 to the power 4, which is 16 plus 1. This is like 16 plus 1, which is 17. Okay, so and this means at this point, we can apply here the distributive law of multiplication, of the fact that multiplication distributes over addition. All right, so, and we use that property of distribution to then say if we have 2 to the power m plus 2 to the power n equals exactly 2 to the power 5 into 2 to the power 4 plus 1. Okay, this is 2 to the power this, 2 to the power this, 2 to the power 9 plus 2 to the 5th power. Now, let's continue. And we can write it like this, or we can say it is 2 to the power m plus 2 to the power n equals 2 to the power 5 plus 2 to the power 9. So we recognize that addition of real numbers is commutative. So we can commute the addition here. Now, a couple of things are important for us. In the first case, we can just, by comparison, we can be able to see, therefore, that m is 9. Right, but also we can see that n is 5. Or, in the second case, we can see that m is 5. N is 9. Okay. So, in essence, these become true simultaneously. So we can write like that. Yeah, this is enough. Right, so we can write this way and say, in the first case, m is 9, and at the same time, n is 5, or m is 5 and n is 9. Okay. So what do we do now with this? In both cases, hence, okay, obviously, let's say this, where, right, where m and n are integers, where m and n are integers, right, hence, what are we able to achieve here? We're able to achieve the summation here. What is the summation? M plus n is 9 plus 5, which is equal to 14. So in both cases, you have 9 plus 5, which is 14, or 5 plus 9, which is 14. So we have that this implies that m plus n is equal to 14. But like we are saying here that m and n are integers. They are integers. So now also we continue to then say if m is 2, We have 2 to the power 2. Okay, let's start by writing 2 to the power m, the given question. Right, so we have 2 to the power m plus 2 to the power n equals 544. Okay, m is 2, so we're just assuming m is 2, so we put 2 to the power 2, 2 to the power n, which equals 544. And we want to actually solve this for n. And so what we're able to obtain here is that 2 to the power n, 2 to the power 2 is 4, which is 540. And therefore, this means that n is the log of 540 base 2. And the log of 540 base 2 is 9.07681. Right, so this becomes the value of n, and hence we obtain the sum of m plus n, and m is 2 plus 9.07. 9.07, right clearly here. 9.07 681. Right, you add these two things, which means m plus n is 11.07681. Right, so we have been able to achieve the sum here. We are able to see, therefore, that the summation is this one, 11.07681. Okay, or we have also this one here. We have been able to achieve for the integer values that m plus n is 14. But also we have that m plus n is 11.07681. Right, moreover, right, moreover, if m equals 1, m plus n equals 544. Right, 544. Right, substitute m equals 1, which is 2 to the power 1 plus 2 to the power n equals 544. 2 to the power n is 542 by subtraction, because 2 to the power 1 is equal to 2 exactly. So if we actually continue with this, we have 2 to the power n, which is 542. And this means that n is the log of 542 base 2, 9.08, 214. 9.08, 214. Okay, now looking at these, we're able to see that thus we have m plus n. Right, we took m to be 1, right? So m is 1 and n is 9.08214, which means that m plus n equals 10.08214, which is exactly the same as follows. Right, so we have that m plus n now is 10.08214. Okay, we've got a couple of possible summations. M plus n here came down to 14, where m and n are integers. But here it came down to this, where you have that m and n are real numbers and not just integers. Okay, also here you have those solutions where m and n are real numbers. What is then the conclusion here? Right, hence we have that m plus n lies between minus infinity and infinity, where m and n are real numbers, like so. Right. Moreover, right. Moreover, we have infinitely many solutions. Infinitely many solutions for all m and in R. It's not just we only have integers, but with infinitely many solutions for m and which are real numbers. And therefore, we have solved this particular problem in detail. Yeah, thanks everybody for your time and attention, and a very good bye to you.